Exploration through innovation.
Exploration through innovation.
And in this we had 4 key objectives. Our first objective was to collect and analyze rock and water samples. All right, in this we have our front equipment located so that we can best drive forward and accurately gain any samples that we would like to retrieve. Our second was to gather atmospheric data. We've got other range sensors for doing this already mounted to our initial prototype. Our third objective was to gather data on underground composition. We have a ground-directed radar so that we can test ground samples and ground density as we travel along through our objective terrain. And our final mission objective was to gather data on seismic activity. We have a deployable base station that we can take to alternate locations that we might feel we could gain more scientific data. They can contact directly through, and we'll talk about it more in just a minute. The Red Planet Explorers have the current company staff. We have 5 staff engineers, a procurement manager, a project engineer. Our president is Stephanie Gunn. Our CEO is Leslie Shashel from NASA. Our major systems, communication. We have 3 different forms of communication located on the rover. On top, we have a line of sight array so that we can have line of sight communication with our landing station and any other devices like our DRM that we might be able to place in other locations. This also is a alternate form of location while we are on the planet. Our second form is a high gain antenna, which allows us to talk either directly to NASA or to an orbiting satellite in a high volume of data. We also have a low gain antenna on there in case the high gain goes out or we need to use 2 forms of communication at once with either the orbiter or NASA itself. All right, our second is the power supply. We have 2 forms of power on the rover. Our first and primary is the solar panels, which will provide us with our largest source of power. And then we also have a GPHS RTG, which stands for General Purpose Heat System, all right, Radioisotope Thermoelectric Generator. All right, what this has is a plutonium-238 non-weapons grade plutonium dioxide ceramic inside that has a decay rate of 87.7 years. So from the initial, it'll take 90 years for it to reach half of its initial potential of power production. It has no moving parts and is not susceptible to much of any damage and or failure at any point. In this, it'll also keep a lot of our key components from ever reaching a temperature low enough that they should ever fail. It'll keep our batteries warm so that they'll always produce at a high rate of power, and it should keep us in a very happy state with constant electricity without any need for light, for wind, or for any other form of electricity. We should get between 300 and 900 watts from this consistently, depending on the model that you would like on your rover. The one we have currently should get about 500. Tools. We have a forward grapple on this for manipulating the environment. It can be raised and lowered so that it can reach just about any height up to about midline with the vehicle, so as we don't get too high and topple the vehicle itself and become unable to use any other systems. We also have a light spectrometer on board near the front so we can go and sample different objects and devices and water samples so as we can get through. Controls, we have independent 2-wheel drive, which is on the back. We have an independent motor for each rear wheel. Sensors, we have electromagnetic, electrostatic, which are our sensor at the top. We also have spectrum, which I've spoken about. Seismic, which is inside the control module. And then we have also imaging. We have 3-dimensional cameras. We have 2 3-dimensional camera banks of 4 cameras apiece, so we can get a full view of the environment around it. And also we have a forward-looking camera, so as we can see hazards that we might be coming up to and the direction we're driving in, and also what we might be manipulating with our grapple arm. Navigation, we have 2 major forms of navigation. First one being radio location, so we can either use our line of sight and our high gain or low gain antennas for communicating with other stations there on Mars. image-based interpretation. So through the cameras, we can interpret where we should be using stars or any other landmarks we might be able to see. All right. Our prototype testing, we did rather well. We were able to achieve 4 of the 5 items to test, or 5 of the 6 items to test, and we were able to retrieve a rock, so we did rather well. All right, the modifications we knew we needed to make. Our key modification was that our front arm assembly was too low for us to access some of the items we needed to access, so we were able to alter our front arm assembly so that it was a little bit higher and we could access slightly higher. The additions. We have 3 key additions because of our increase in funding. We added a manable capsule, which also allows us to put on extra batteries and computing capability. We added extra solar panel on the rear, so we have a higher amount of electricity to work from. And then we also added this dropper module called a DRM. All right, the Deployable Research Module. It's got a cost of approximately $20 million and has a high number of capable testing that it can do in place. Our budget, as you can see on the board, is pretty self-explanatory. We came in $67 million under the amount that we've been authorized so far, and we believe that we can make great strides with the funding we're still left for future extra modules and or power improvements or any other improvements that you would like to make to your current rover. All right, this is why the Red Planet Explorers are the best bang for your buck. We are budget-minded, but always looking for true innovation in your constraints. And this, I give you, is Billy. Have any questions?